Okay, in this video we want to take a look at problem number 3 of the recent group test, and we have a chord AB of a parabola y equals x squared moving up from the vertex at 3/4 units per second, always remaining parallel to the x-axis. So let's stop for a moment and take a look at the scenario. Okay, so first of all we have the graph f of x, or y equals x squared. Alright, next then we have the chord AB that is parallel to the x-axis and is moving up along the y-axis at a rate of 3/4 units per second. And so we can see the chord AB moving up a little bit more, a little bit more, and this is all happening at a constant rate of 3/4 units per second. Okay, we're going to go back to the original problem and see what we have next. Okay, next we have triangle ABC that's formed by the chord AB and the two tangents to the parabola at A and B. So now we need to go back to the graph and construct those two tangent lines at A and B and see the triangle formed by chord AB and those two tangent lines. Alright, the first we have the line tangent to the curve at point A. That's the line in blue there. And now we have the second tangent line, tangent to the curve y equals x squared at the point B. That's the other line in blue. And you can see that these two lines definitely do intersect, and that point of intersection we're going to call C. And so we have this triangle formed there, ABC, and I will put them all in bright green. And there we have it. So we have a triangle formed by the chord AB and the tangents to the curve at A and B, and they meet at point C. So we have this triangle ABC that we can now talk about its area. And so now we have the area of the triangle in purple, and for this particular setting, for these particular settings, we have 25.51 centimeters squared. Now I've also listed the coordinates of A and B on the screen so that you can see them. A is at negative 2.34 and B and is the x coordinate of point A, and its y coordinate is 5.46. The x coordinate B is 2.34 and its y coordinate is 5.46 also. So you should see that as AB, the chord, moves up and down along the y-axis, that is going to affect the slopes of the tangent lines, and it will also affect their point of intersection, and so the triangle will change in area as chord AB moves up and down along the y-axis. So let's see if we can change a couple of settings on that. Okay, so the first one we'll look at is where A is negative 1, comma 1, and B is 1, comma 1. And so we have an area there. It's a triangle with base 2 and height 2, and so it has an area of 2 times 2 of 4 divided by 2, which is 2. So it has an area of 2. Let's change it again. And so now we have the points negative 1.41 and 2 and 1.41 and 2, so that the chord AB moved up the y-axis, and you can see that everything changed. We now have an area of the triangle to be 5.65. And I guess what you might want to be noticing here is that as the chord AB moves up along the x-axis, its height above along the y-axis, its height above the x-axis is the same as the distance the vertex moves below the x-axis. Alright, so this is the final setting, and this is the setting that we are trying to find the rate of change of the area at. Here x or A is the coordinates of A are negative 2, comma 4, and the coordinates of B are 2, comma 4. And you can see that the chord AB is 4 units above the x-axis, whereas the vertex C is 4 units below the x-axis. We still haven't proved that that will always be the case, that the distance above the x-axis will be the same as the distance below, and that is something that we should demonstrate conclusively. But right now I'm going to take this snapshot and bring it back to the problem and continue in the next video.